Second solution, same setup, black circle, two radii, R, and then blue isosceles triangle. The apex is at the highest point of the circle, so you can think of the base as horizontal. Earlier, I used the variable x to represent the entire height of the triangle. What if we use x to represent not the distance of the base from the apex, but let's use x to represent the distance of the base from the center. So there, x. And then here are some possibilities. So if you make x longer, so as you make it longer, then you can see that it can go no higher than the radius. You get a much taller triangle. All right. But you could also have the base not be below the circle, below the center, but say it could be above the center. All right. So in this case, you can think of x as being negative. The idea is to think of this vertical line through the center as an axis. Okay, I suppose you could think of it as a y-axis, but instead of coordinates being positive above and negative below, then in this case we're going to think of coordinates on this axis to be positive as you go down and negative as you go above. So for example, if x is 1, then you're referring to the isosceles triangle such that the base is 1 unit below the center. But if x was negative 1, that would correspond to the isosceles triangle where the base is 1 unit above the center of the circle. Alright, now we're going to use the same area formula. The area of this triangle is 1/2 base times height. So from this figure, we see the height to be r plus x. All right, so you're probably wondering the condition there, r plus x, if x is greater or equal to 0, I'll explain that. But for now, it is clear that, as in the previous solution, we need the base that's the base is going to be double the length of this blue segment. Sorry, this black segment, I don't know my colors. And then this black segment is part of a right triangle with dimension one side x and hypotenuse r, so you have the square root of r squared minus x squared. Alright, what I just wanted to point out is, well, if x can be negative, then it could go in the negative direction. So that's why in the domain that I've indicated here, you can think of x as running from negative r all the way to positive r. Positive values of x mean the base is below the center, and the negative values of x mean that the base is above the center. So there. Now, just so it's clear, all right, x can only be a dimension if x is greater than or equal to 0. So some of the eagle-eyed students might be wondering, okay, what if x is negative? X is in green, so x can be negative. Then x cannot be a dimension. Well then, in that case, this green segment would have dimension negative x. So remember, if x is negative, then negative x is going to be positive. So this green segment, in that case, it would be, well, the length of this green segment. And then let's go back to the blue triangle. What then would its height be? Its height would be part of this red radial segment less the length of this green segment. So what remains will be, as I'm tracing, that's going to be the height of our blue triangle. So therefore, the height in that case would be r minus the length of this green segment, negative x, if x is less or equal to 0. And then as for the black segment, its length, fortunately, wouldn't really change because it's still going to be, according to the Pythagorean theorem, the square root of the hypotenuse r minus the square of the length now, which is negative x. But whether you square x or negative x, it's going to be the same thing. So fortunately, you don't have to deal with a second formula. This black segment will still have length the square root of r squared minus x squared. And fortunately for the height, it would end up being the same because even when x is less than or equal to 0, and we argued the height of the blue triangle would have to be r minus negative x, but that still reduces to the same thing, r plus x. So no matter what, all right, the height of our blue triangle would be r plus x, and its base would be double the square root of r squared minus x squared. And that is what's going to explain our area formula. 1/2 base, double this radical, times the height, r plus x. Uh, the only simplification really that you could do here is the 2's, and then you could use the product rule to differentiate our formula for A. As in the first solution, to avoid the product rule, you could rewrite r plus x. Here, I'm tracing with my mouse. You could rewrite this as the square root of the square of r plus x, then multiply it to the square root. So you get to write that entire thing down as a single square root. So you don't have to use the product rule. That's an option you could take, but I'll keep the function a of x as it is. The only thing I'm going to do is remove the 1/2 and 2's neutralizing each other, and use the derivative using the product rule just so we don't forget. So the square root of r squared minus x squared times the derivative of r plus x as is 1. Plus this time we get to copy r plus x and differentiate the radical. So it's going to be double that square root in the denominator, r squared minus x squared. Then chain rule, the derivative of r squared minus x squared is negative 2x. So that's the first run of a prime of x. Now we could write everything as a single fraction after canceling this 2 and this 2. So just pretend that those 2's aren't there anymore. So under the same denominator, you have r squared minus x squared radical, and then this square root times that square root is r squared minus x squared. And then x with a negative sign multiplied to r plus x. So this is what you have. And then you could simplify that minus x times x, and negative x squared minus x squared. So you have negative 2x squared plus r squared minus xr. I skipped a single line, but it turns out that the resulting numerator is factorable. Yay! You verify it's negative of the quantity 2x minus r times x plus r. Then it's the same denominator. So for critical numbers, when will a prime be 0? When will a prime be undefined? When will the numerator be 0? When will the denominator be 0? So keeping in mind that x belongs to this interval, so this is an essential thing, an essential component of the solution. Identify the domain, because you might end up, after processing the derivative, you might end up with what you think to be critical numbers, not realizing that they're unacceptable because they're not part of the domain, which you miss because you didn't take the time to identify the domain. So do this after you've set everything up. What's the domain? Alright, so for the denominator to be 0, x is r or negative r, which are already the endpoints. And then the numerator will be 0 if from the second factor x is negative r, that's an endpoint. And additionally, the only thing we gotta add is from the first factor, that's going to be 0 when x is r over 2. So that's the only critical number that we have to add. Area formula continuous, domain is a closed interval. We just need to evaluate the area function at the endpoints. Negative r and positive r, that's an easy enough evaluation because if x is r or negative r, this radical is going to be 0. So there you go. And then if a is r over 2, then plug it into this formula, and that's going to give you this 3 squared of 3 over 4 r squared. That's definitely larger than 0, so this is the maximum value. This is the largest possible area. So if you're probably wondering, why is our critical number different from the critical number from the first solution? Well, it's because x, if from x in this solution means a different thing from the variable x in the other solution. But in the end, the largest triangle we were able to come up with here in solution 2 should be equivalent to the largest triangle from the first solution. So you could compare that. The areas are the same, 3 squared or 3 over 4 r squared. So what are the dimensions? The dimensions are the height. This time the height is not x, but it's x plus r. And so if the critical number is r over 2, then r plus x, that's going to be 3 halves of r. You might remember that to be the same height from the previous solution. And then the base is double this radical, so double the square root of r squared minus x squared. Using x equal to 3 halves as our critical number, you are going to end up with square root of 3 over r. Here's the same dimensions from before, so I don't need to explain anymore why it would follow that the triangle with the largest area, which with this triangle being isosceles, it should be equilateral.